Whoa.
I read the heartbeat on the space monitoring tool.
No.
Heartbeat
Shared yeah, everything's good. There's no power.
right.
There's no power. It is a sand. Well, it's okay. There was a wave or something, copy bit by bit. So I reckon we're going to start.
Oh, synchronize the data. Yeah, you really want a dedicated second network to do that.
Okay, no worries. All right, so we will start. We have a lot of ground to cover today. So we only have 50 minutes. Sorry to interrupt.
Oh, that's all right, no problem. You'll get to do the same thing to me tomorrow twice.
So yeah, we have 50 minutes. These slides will be available online. So if you have questions, you feel free to ask them, possibly even to us. Just interrupt me, just wave your hand. So I'm here to talk to you about best practices for MySQL high availability. How many of you here use MySQL? Okay, that's all of you, most of you. How many of you have a HA set up for MySQL as well? Okay.
You mean like
replication?
Yeah, replication.
Okay. All right. So I'm Colin Charles. I've been in the MySQL world for about 15 years now, at various different companies working on the same product. Kind of scary. I'm going to tell you how to choose a good HA solution. I'm going to tell you about how to use the various high availability tools that exist. For example, the ones that allow you to do automatic failover. This seems to be very popular amongst NoSQL solutions and so forth. But in the MySQL world, you have external tools. I'm also going to talk about clouds. How many of you use AWS or Rackspace Cloud or something? Okay, cool. And sharding. As you grow larger, you will shard your data. So some key things about the MySQL world is not quite to the top. Some key things about the MySQL world is that your application sits all the way at the top via some kind of connector, be it PHP, Java. There's a connector to pretty much every language out there. For most of your HA needs, it's through the replication API, which I'm kind of blocking apparently. it's all through here. The replication API has a binary log, a real log, and there's an open API. That's where all the changes happen, including tools like Hadoop Apply that allow you to push data directly into HDFS in real time, so you can analyze data using Hadoop tools. But we also have another extension via storage engines, so you can have a highly fault-tolerant database via the Cassandra storage engine. So Cassandra is a backing store. MySQL used to be the only unique database in the world that supported multiple storage engines. Typically, the most common was InnoDB and MyISAM. Now, MongoDB 2.8 will also support storage engines. So it's still not like released or alpha, but you can get that on GitHub. So it's not the second database that has storage engine support. So basically, you have HA through those two methods.
So is that 5.6? Is the pluggable just 5.6?
The pluggable storage engines came since 5.1 actually.
Oh, really?
Yes. And we have the concept of storage engines before, but the pluggable storage engines came through in 5.1.
So Cassandra and all those can go back to 5.1?
The Cassandra storage engine is special. It generally only works with MariaDB because of something called dynamic columns. But MariaDB is part of the ecosystem, so I'm including it in this talk. I will go a little bit more in depth with the Cassandra storage engine at the MariaDB talk later. And of course, you can also have high availability before the connectors, where you use typically tools like HA proxy or other various proxies, including MaxScale or Fabric. Now, this technology, MySQL, has been around for nearly 20 years. Next May will be 20 years old. And there are many branches, Cortana Server, MariaDB, and lately even something called WebScale SQL. So there are a whole bunch of branches. MySQL Percona Server and MariaDB are well supported by pretty much every MySQL support company or database support company out there. Now, why I include all this is so you understand the entire ecosystem. And it's also worth noting that if you use Linux, modern Linux distribution, they're generally shipping MariaDB, not MySQL. So when you ask for MySQL, you get MariaDB. So, do you have a HA solution besides prayer? So, what is HA? And it's a pity that you can't see the top, but HA means many things to many people. But on the top left-hand corner, it could mean things like performance and scalability. You can measure that via throughput, which is typically transactions per second. And you can also measure latency, which is usually measured in percentiles. I don't know why it's all opposite, so I should keep on having to look back and forth. On that side, you also have durability. So if you have an ACID-compliant database, the D in durability means that the data is actually committed to disk, not just in memory. Now, of course, you're probably familiar with the fact that now there is things called the cap theorem, which doesn't commit data to disk because you have it spread. But MySQL, by and large, is ACID-compliant database. At least the engines that are worth talking about, like UniDB and TokiDB. And part of that also involves you having things like good replication, so snapshots, point-in-time recovery, backups, etc. Replication is also all about redundancy, eliminating a single point of failure. And also nowadays you have clustering, which also includes failover built in. This also includes things like monitoring, recovery, and so forth. Now, you may be familiar with something called MySQL cluster. MySQL cluster is a marketing word for NDB cluster, which is a network database. You can also create a Galera cluster, or you can also create a cluster of replicated MySQL databases. Master-slave, master-master, Hit56 and MariaDB 10, you can have master-master easily with global transaction ID and so forth. So I like to say that HA is like a very well-stocked bar. You can never really drink the bar dry. Because we now have over nearly 20 years of this product improving, and replication came with statement-based and row-based and all these features. There are a huge chunk of tools available. And actually, I'm only going to focus on the open source tools that exist, because with nearly 20 years, you generally don't need to buy closed source tools. So, uptime. Everybody measures uptime. If you log on to Linux, you can type the uptime command. But uptime for data center purposes generally translates to levels of availability. And everybody claims that they have 5 nines uptime, which means 5.25 minutes of downtime per annum. Yeah, that's pretty hard to achieve without multiple replicas. And typically, there were studies done by Kingdom and even Gomez that say only a fraction ever get past 3 nines. The average hovers around 99.6% uptime. So generally, you are down for anywhere between 1 to 2 days every year. This is why the recommendation is to replicate. Keep multiple copies of your data everywhere if possible.
What was the definition of down? Is it unscheduled or scheduled?
Downtime can be unscheduled and scheduled downtime. Scheduled downtime allows you to plan, so you usually have a replica available for failover so that your services never get interrupted. Unscheduled downtime is the one where you don't plan for, and if you don't have a solution that can keep you up and running, you may have switchover time.
Because some people don't calculate the scheduled downtime.
That is true, and we'll come to that later down towards Amazon, where they don't calculate scheduled downtime for the RDS. And actually, you lose that scheduled downtime, which is not part of their guarantee. But generally speaking, your service needs to be available. So if you want to argue on this topic of do you calculate scheduled downtime or not, think of an e-commerce store. Are you allowed to go down? Because you measure on every minute you make X transactions. If you really do go down, you've lost X transactions, which actually translates into a dollar value. So the best thing to do is to measure both scheduled and unscheduled downtime as a total whole, not as pump. So with regards to MySQL, just using regular replication guarantees you about 99% uptime. This is either statement-based or row-based replication. Once you start adding tools like ERBD or NHA or even tungsten replicator, you can pretty much guarantee you a 3 nines uptime. If you really want 5 nines uptime, NDB cluster is generally very good at giving you 5 nines uptime. This stuff is even used in the US Navy on their warships to make sure that there's no split brain issues with missile warheads being ejected. Apparently, this is a pretty important thing. And actually, this NDB cluster was also ported to the Windows platform for that. So if you actually want to find out more information, go to dev.mysql.com and check out the customer list, which includes the US Navy. But then but the most common use for this is obviously not military, but telco. 5 nines uptime is typically important for telco because you need to have home location services because you keep on moving from cell to cell, and the cell needs to know you exist. Typically, that's what 5 nines uptime is for. An NDB cluster is usually used in the telco space for this exact purpose, to know that your cell phone has the rights to make service, is located in this location, and so forth. And then there's, of course, other solutions like SAN, MMN, which we'll all talk about. And typically dealing with downtime at scale, now back to address, should you even bother with scheduled downtime, is that when you are at scale, think of scale like Facebook scale, etc., you don't even measure with one machine going down. One machine going down doesn't even trigger people to come in to fix it. People go home at 5 o'clock in the evening and they get multiple machines down, which they will fix tomorrow, because there's so many replica sets available of the data that it never really affects the user. The user doesn't know that a machine has died. HA is generally all about redundancy, and in the IT world, there are so many ways to make your database server redundant. You use RAID, use clustering, use geographical, typically data centers. Especially when you use the cloud today, you have multiple regions. You don't just use one region. And when Hurricane Sandy came to hit New York, a lot of services went down because data centers were flooded. So generally, you don't only want to keep in one region, you have multiple regions. And HA is really, even biological. You have HA because if you lose a kidney, you have a second one. But we haven't been modified enough to, if you lose a heart, you have a second heart. So durability is pretty important. When you're dealing with databases, you have to make sure the data is committed to disk. If it's not actually written to disk, by calling fsync, you actually may lose data when the power is pulled out. And this is important because later on we'll talk about something called a group commit algorithm, where we don't actually call fsync each and every time, we call it in a group because it actually improves performance. Fsync calls in Linux tend to be pretty expensive. Then with databases again, you need to guarantee the A in ACID, which is atomicity. You need to ensure that it's written in a transactional order so that when you need to recover, it's also recovered in a transactional in-order method. So I reckon HA is generally much harder for databases overall because this isn't just static data usually, it's constantly changing data. People are doing inserts, they're doing updates. It doesn't really matter if you just select. Now, one method not to do high availability is client-side XA transactions. Typically, there is something called HAJDBC, and many people write applications and say, we don't need to worry about the database, we will just write the same set of data twice. This typically causes data to be out of sync and gives you lots of problems later on. It seems like a simple concept, but I think it's better if you rely on what's available in your data store. How many of you here use InnoDB in production? Okay, not all of you, this is surprising. But most of you use MySQL. How many use MyISAM in production? Okay. So since 5.5, I think the default database now is InnoDB. But if you're using older versions, you still do use MyISAM as the default database. So important thing about InnoDB is that it has this concept of recovery time. InnoDB tends to be used in most large systems, and the general advice is to keep the log file large, keep it up to as large as 4 gigs in size. But the larger it gets, the longer recovery time you have. And a good example is Wikipedia. They kept 256 megs of logs, but then they have reported up to 40 minutes of recovery time when the server's crashed and needs to recover. So even with just 256 megs, it gives you that long. But the average is anywhere between 5 to 10 minutes. And there was something called InnoDB recovery stats, which is not ported to the 5.6 branch of Pagona server or even MariaDB 10. And it was never in MySQL 5.6 either. But this information is now exposed via InnoDB statistics, so you can get that as well. Now, commonly people like to buy SANs. If you buy big databases like Oracle, they usually sell a SAN with it, or usually buy a SAN. Now, SAN is the idea of scaling up, whereas MySQL gives you the idea of scaling out. There's no reason to buy one big usually. So typically with regards to SAN, I'd say it's generally complex to operate. You don't only operate it yourself as a DBA. You have to typically get like a SAN domain controller to run things for you. SAN also includes failover time, anywhere between 1 to 30 minutes of downtime when your SAN actually fails. SANs are really expensive. I don't know if you want to buy a couple SANs. Then there's also redundancy through disk replication. Anybody here use DRBD in production? One person. Okay, excellent. This involves you actually making use of Linux system admin skills, not just involving a DBA typically. Unless you're a small shop, then you're probably everything. And DRBD is RAID over Ethernet. It's fully synchronous. The advantage of this is that every bit of data written to the active is also shipped to the passive. And why is it passive? Because you can never access that second set of data while DRBD is running. There's a hack around this, obviously. People tend to run DRBD both ways, so both are actually active, but parts of the data is passive. This is complex to do, but can be done. And for anybody using something like Amazon RDS, you probably are already using DRBD when you select the option to have a replica set. The high availability option is most likely based on DRBD. But the DRBD has disadvantages. It has failover time. Typically, we've seen about 5 to 10 minutes. This is also true in RDS. It also has a performance hit. The worst case is you're only getting about 60% of your single node performance compared to the 100% that you should be getting when it comes to writes. So when would you use DRBD today? Because DRBD was a generally really good solution, I'd say, before replication improved. But replication has improved so much now that I reckon now you'd use DRBD if you're already used to SAN, or when you cannot ever lose a transaction. So maybe in financial services or something, you really cannot lose a transaction. Then it makes sense. So MySQL, multiple methods of replication. You have regular replication. Anybody who uses Tuxedo Replicator or heard of Tuxedo Replicator? Okay. Galera cluster. Yep. Okay. NDB cluster. We vaguely talked about that. Generally speaking, this is the way to scale out MySQL today. MySQL replication was always generally statement-based, which means that when you execute the statement on the master, it gets executed on the slave as well. This can lead to obviously out-of-sync data from time to time if you have dangerous transactions, like it triggers solve procedures, functions with 2 or more auto increments. So since 5.1 now released in 2008, if I'm not mistaken, you have mixed mode replication as the default. That means it always gives you statement unless you hit a dangerous transaction or an unsafe statement, where it will then shift to role-based replication. Now, since 2008, there's been 5.5, 5.6, and there's been the various Pagona servers, the MariaDBs. So there's probably no more reason to be running 5.1 any longer. Should probably be moving along. Why is MySQL replication good? Because it's really fast. How does it become fast? Because it's asynchronous. You can keep on writing data as a master, so your inserts can take like 20, 30 milliseconds, but there's no guarantee your slave's going to get it. So replication is easy to set up, but if it's also really easy to break if you don't monitor it. So that brings us to the point of the semi-sync plugin in 5.5, which allows you to write to a master and guarantee that one slave receives what the master has gotten. This will actually increase commit time. There's obviously latency, but it now ensures the transaction is on one other slave. This becomes important when you start using tools like that automate payload for you. And then, of course, people always say we want fully synchronous replication. We want to ensure that when it's written everywhere. But actually, this would give you a performance hit, but everybody wants write everywhere to multiple machines and no performance hit. This is not realistic. And fully synchronous comes via Galera largely. There have been amazing amounts of features that went into MySQL 5.6. The most important, I would say, is global transaction ID and the server UUID. So all servers have a unique identifier, and each transaction has a global identifier that is unique. So if a machine goes away and comes back up later, you can just point to a transaction ID that says, hey, I want to get information from that, from missing transactions. This is really, really powerful. The disadvantage of 5.6's GTID is that turning it on in an upgrade scenario is kind of hard. There's no easy way to turn it on without actually losing service time. You actually have to restart all your masters and slaves at the same time, which is why MariaDB 10 did it in a different way, by appending the GTIDs. This will eventually be fixed in 5.7. But then many other interesting things like checksums in the binary log to ensure that if the slave receives a row, checksum doesn't match, it stops replication. This is important so the slave isn't receiving garbage, which is possible entirely through bit flips, etc. And then the slave has bad data, and when you finally do switch over, you go, oh, I didn't notice this was happening. Oh, and a lot of these features that you see in MySQL 5.6 was largely in MariaDB 5.3 already. So we're pushing things, making sure Oracle continues doing excellent engineering work with MySQL. Now, if you happen to be interested in MariaDB 10, we have things like start transaction with persistent snapshot, which allows you to have a full non-blocking backup at the point of time in the transaction. This is a useful feature when you want to provision new slaves. This becomes extremely useful when you want to use Galera cluster as well. This feature is useful enough that you don't have to run flush logs, and Percona has ported into Percona Server 5.6 as well. So both Percona Server 5.6 and MariaDB 10 come with start transaction with persistent snapshot. Another common problem is that replication can be slow. Slaves can go out of sync because the SQL thread is generally single-threaded. With parallel replication, on a per table basis, as opposed to a per database basis or per schema basis, which is what you get in MySQL 5.6, slaves generally perform as fast as the master. And this is important when you have multi-source replication where there are multiple masters, so you need multiple slave threads. This is generally a good performance boost. And threads are, all the slaves are now multi-threaded as well. They can recognize multiple slave threads. And then there's multi-source replication. Whether you want to do real-time analytics like FunPlus Games is doing, or whether you want to do shard provisioning like Tumblr did, and still does. They used a very alpha version of MariaDB production for shard provisioning. Multi-source replication exists. Nothing fancy about this feature. Other databases have this too, just that it was not in MySQL. It'll come in MySQL 5.7 as well. So replication can get out of sync for a myriad number of reasons. Here are just a few. Sometimes people have the master in MySQL and the slave in InnoDB. This actually does cause problems. Most commonly, the replication can also get out of sync. If you've done your architecture properly, it's just like you get bugs. I mean, everybody is human. So, to prevent all of this, I suggest you check out Percona Toolkit. How many of you use Percona Toolkit? No. Okay, you need to start using it. download this piece of very useful software. It has maybe about 20 tools, but for HA purposes, the most important would be PT slave find, which finds slave information from the master. PD table checksum. This ensures that you have replication consistency across your entire cluster of databases. Now, PD table sync. Once you've got the information from PD table checksum, you can actually sync the data, but you don't want to do this unless you have backups, because it actually changes live data. Now, if you're interested and you have MySQL on your machine, you can run MySQL binlog on a binlog file in your data directory, and you'll see something like this if you do statement-based replication. You'll actually see the entire statement insert into auto data values ATES2 actually in the statement. And you'll notice that internally we do have an XA implementation, which is represented by XID. You can set the binary log format to be statement, row, or mixed on the fly on a per query basis as well if you want. You can set it, as I said, on a session level. And we also provide replication filtering dynamically inside MariaDB, which eventually will come to MySQL. So if you want to filter some queries on the master so it doesn't go to the slave, this is entirely possible. Why would you do this? Maybe you don't want this slave to ever have any updates for audit purposes. It actually is surprisingly useful for certain industries. And then row-based replication, some Google group. If you copy and paste what I folded, it'll actually run in the MySQL server, it'll execute. And you notice that the XID has now bumped up to 416, mainly because when I did this example, I went from 414, 415, 416, I executed 3 statements. Now, if you are using Linux distribution today, you may notice that you will see an error, like found invalid type in binary log, especially when you installed MySQL from your distribution, which is installing MariaDB, and then you installed MySQL 5.6 from the Oracle YAML repository. You may have issues, and one reason is because the GTID formats are different between 5.6 and 10.0. So you got to make sure that you use the correct version of GTID. So version 3.4 is what comes in 5.6. Version 3.3 is what comes in MariaDB 10. Well worth noting. Don't want errors. Oh, and if you have global transaction ID enabled, at the top, you'll actually see unique identifier. There is a feature called slave prefetching. What happens is when your slave dies, and if you bring it back up again, the data is cold, so it takes a while before the slave is actually performing. So one way to do that is via slave prefetching, either via something like replication booster or tungsten, or to use InnoDB fake changes. What that does is it replays statements, and then it'll roll it back at commit. So any inserts, update, deletes are actually replayed to the slave, thus warming up the buffer pool, and then but when it's time to actually make a commit, it actually rolls back. So there's actually nothing, there's no performance loss, except this helps warm up the buffer pool. This is useful so that your slave actually comes back and can be used in a usable fashion in your topology. Now you can only do this in Pagoda Server or MariaDB. Tungsten Replicator, useful piece of technology. Basically, it looks at the MySQL binary logs, and then it adds a layer on top of it by reading it and then shipping it. So it actually makes use of more network traffic. It, for the longest time, supported global transaction ID and multi-threaded slaves. One of the cool features I think that it has is that it has heterogeneous replication. You can go from MySQL to Oracle and Oracle to MySQL back and forth easily. Why will we focus on Oracle? It works with MongoDB, Postgres, as well as lately Hadoop. This is, I would say, quite useful. And it does various amounts of things. Generally, the product is completely open source. What is closed source in the enterprise version is deployment across geographies. So you don't actually need that. For the replication, HA stuff, the open source tool works just fine. But you'll notice that it has a lot of overlap. GTID, multi-threaded slaves, it's all overlap. So what would I recommend you using Tungsten for? MySQL to Oracle replication, Oracle to Oracle replication, so you don't pay for Golden Gate. This makes sense. Or the trick to turning on GTID in 5.6 without restarting your entire topology is to use Tungsten. Let Tungsten take over replication, turn on GTID in a rolling fashion, and then get rid of Tungsten. So it's a dual trick. Galera is really cool. Galera is the hot new technology. It can be referred to as Percona HDB cluster or MariaDB Galera cluster. If you use OpenStack and all these other tools that require HA, they always recommend you to use Galera. It works inside of MySQL. It uses a replication plugin called WSRep. It replaces the MySQL replication layer to ensure that everything, your data is committed to all nodes or no nodes. So this is fully synchronous replication. But it can also work alongside asynchronous replication. Why would you do that? Because you have one data center in Seattle, fully synchronous with 3 nodes in that data center, but then you also want to replicate the data to, say, Singapore. Typical AWS example. You may want to do that asynchronously to Singapore, where Singapore also has 3 nodes running fully synchronous, but the over the ocean stuff happens via asynchronous replication. It's very unlikely a user will hit Seattle and in the same session hit Singapore at the same time. Very unlikely. It makes use of a quorum algorithm, so you need a minimum of 3 nodes. Quorum algorithm suggests that if you only have 2 nodes, when one node dies, that node only represents 50%, so it can't actually say this is now the new master. It makes use of optimistic concurrency control, so transactions are done locally on each node, and then when it's time to commit, it then gets spread to the other nodes before you actually get an OK, or you may get a rollback. It actually works pretty well in AWS. If you run this in EC2, you're getting about 300 milliseconds per user. Of course, there are issues around it, like you may have deadlock errors, so you need to actually plan before migrating to Galera. It's not like a drop-in replacement for regular MySQL. It also obviously does automatic node provisioning. And MySQL 5.7 will have something similar to this called group replication. MariaDB 10.1 integrates this inside of MariaDB, so it's not a separate server you need to download any longer. So more options coming your way. And popular technology. 3 releases every year, several distributions available. It's open source for more than 5 years now. The MariaDB version actually will work with multi-source replication, parallel apply, etc. Some things you don't get with the regular Percona version. And I think one of the good things is that we've seen people use this a lot. People have migrated from Oracle RAC to Galera cluster. Greets was one of these people that did that. HP DNS as a service runs Galera cluster. Mercado Libre down in South America runs it. Many telcos are starting to play around with it, so there are huge chunks of people actually using Galera nowadays. It's been around for 5 years. There's also MDB cluster, which I already mentioned earlier. This typically is found in telcos. You generally need about 5 nodes to start. 1 for monitor, 2 data nodes, 2 SQL nodes. Upgrading NDB cluster is actually pretty complex. Typically, you end up having to run about 50 commands to upgrade a cluster, which is why this tool, there's so many tools around it, like there's an enterprise monitor and then there's several lines cluster control, that they expect you to pay for it because they know if you're already using NDB cluster, you probably can afford to pay for management tools. So, quick summary of replication performance. You have SANS, DRBD, Galera. I highly recommend regular replication and Galera overall. Now, what happens when it's time to handle failure? How do you find out about it? Do you poll? Once you've found out about it, what do you do about it? Also very important, you think about how you protect data integrity. And another thing that I guarantee you don't want to do is have 2 masters where both can actually be written to, because then you have out of sync data. So this is why you shoot the other node in the head and ensure that there is no split brain. Now, is fully automated ever really a good idea? How many of you here use GitHub? Okay, so GitHub had an outage sometime last year for nearly a day. Everybody was so productive that day, right? Their downtime was caused by a series of automatic failovers. And this is why fully automated may not be such a good idea. If you go to GitHub's engineering blog, they have a nice case study as to why fully automated didn't quite work for them. Because sometimes you may actually have false alarms. Typically, you don't want to restart all write connections when you have false alarms. Sometimes you have repeated failovers. Maybe your master's just overloaded, and it's time to increase capacity. So you use a tool like MHA, it actually doesn't allow you to failover within an 8-hour period. Also, before GTID, you may have to ensure that you have to encounter data loss. And then when the machine, the old master comes back up again, you actually have to munge the bin logs to find data that was lost. This is tolerable if it was like a social network, but maybe not so tolerable if you were like a bank. And of course, we talked about split brain. There are multiple frameworks to handle failure and failover. We'll start with the one you should not use, MySQL MMM. This technology has been around since 2009, but I reckon since about 2011, their website was updated to say, do not use this tool. You should probably take your advice, do not use this tool. I will include cluster control only because this is the cheapest tool that allows you to, has mostly open source components, but requires you to end up still having to pay to maintain either NDB cluster, replication, or Galera cluster. This is the only Galera cluster front-end tool that exists today. So that if you are using Galera cluster and rolling it, you need to either do things manually or use cluster control. And obviously it does a whole bunch of things like handles hybrid deployments, and you can also have HA proxy configured inside cluster control. It's a useful tool, but it costs money, and we're not going to talk about it. MHA, this is an interesting tool. Has about 10 active contributors. It's used at multiple places, including South Korea's SK Telecom. It's used in defense. It's used at Facebook even. So this is a relatively useful tool. You have a master, slave topology. You can have the monitor multiple topologies of masters and slaves. You can choose if you want to do an automated failover or if you want to be informed and then do a manual failover. You can also use this for online switchovers like schema upgrades. It's generally quite easy to set up. It takes anywhere between 11 to 20 hours to set up, test, and get running in production. This is a tool I highly recommend you to check out. And it has all these wonderful features that work with, MySQL 5.6's GTID. It also allows you to have the binlog streaming server working, and there will be a next release in less than 2 weeks now. In the MySQL world, we follow a conference-led development cycle. So typically we have releases in April and another release sometime in November. Not to be left out, Oracle made MySQL failover and MySQL RPL admin. This basically only works if you have Robo Transaction ID enabled in 5.6 and greater. So it's not a tool for you to use with previous versions. And it also is an MHA replacement, targets one master and n slaves. But when you have GTID enabled, it's worth noting that things like you need to enable something called log slave updates as an option. And this ends up making you have more log space used, so you're actually losing this space when GTID is turned on. Of course, the monitoring node here is the single point of failure. Also, errant transactions will prevent the failover, and this will happen silently for you. What is an errant transaction? When your application accidentally inserts something into a slave. This happens more often than you think. There are also cluster suites. Anybody who use Heartbeat, Placemaker? Okay, Red Hat Cluster Suite. This is generally very robust. Presumably, when you're running this, you set it up with things like Puppet. You don't actually set it up manually. Writing config files manually is quite painful. And there's a tool in the community called Patona Replication Manager that provides pacemaker agents that work with MySQL application as well as Galera cluster nowadays. So if I were you and you happen to be using pacemaker, check out launchpad.net/patona-pim. So if you all have, if you do use this, it's well worth checking out. A new technology that came out this summer is MySQL Fabric. Comes from Oracle. Also, again, requires you to have GTID turned on. Has no users in production yet, but it's generally there to manage MySQL farms for high availability as well as down the line sharding. There's also MaxScale. Also, this one has a lot of community interest, but generally speaking, I wouldn't recommend you to use this today because it's, a release candidate, still pretty early. But one of the cool uses is that it helps as a binlog server that allows you to replace intermediate masters. And this is actually used at Booking.com, and they've written nicely about how they've tried this in testing. I'm gonna have to move a lot faster now. You generally need a load balancer. Highly recommend that if you're using a load balancer, HA proxy is the load balancer of choice today. Make sure that when you are thinking about HA, you have the load balancer also HA, so you have maybe 2 HA proxies running, because the load balancer can fail as well. The JDBC and PHP drivers that come with MySQL today, so you get them from dev.mysql.com, also come with the option to do read-write splitting, load balancing, and round robin. This could be useful for you as well. Is clustering and making things more complex part of the solution or part of the problem? Nice white paper, Causes of Downtime in Production MySQL Servers by Baron Schwartz and Vivek Kotak says the number 1 cause is human error, yes, and the number 2 cause is the use of SAN. So with MySQL, simple is better. Simpler is better. Keep it simple, Sally. The KISS principle. So I know that there's some of you here that use MyISAM, and MyISAM with HA is hard to do because MyISAM itself doesn't support transactions. So things like DRBD, Galera cluster, they don't actually even work with MyISAM. They tell you to use InnoDB. So generally speaking, you should probably be InnoDB based because people know workarounds in InnoDB. But there are also like increasingly other storage engines that are shipped like in MariaDB called TokiDB, which makes use of faculty indexes. It's unfortunately it's not a drop-in replacement because it doesn't support things like foreign keys, but it is an increasingly good alternative. So this is a quick summary of your choices overall, which you can read in your own time. And the conclusions for choice is generally simpler is better. MySQL replication today is preferred over using something like DRBD, which is probably a good solution when MySQL was still at the 5.1 days or 5.0 days. And it's obviously preferred to not using the SAN. And the choices of sync or async replication is entirely up to you and what your application can tolerate. I'd say GTID is quite good, so 5.6 or 10.0 are good things to be using. And Galera overall, wonderful stuff. And what about clouds? So as this gentleman here earlier was saying, SLAs usually don't include the scheduled downtime, and that is actually entirely true with many cloud services. They tell you they can give you 99.95% uptime in a calendar month. AWS guarantees this, for example, which basically says something like, is it like 20, 22 minutes of downtime? But then they don't include the 30 minutes a week that you have for scheduled maintenance. So this is in the terms and conditions. So once you take into consideration scheduled maintenance, you've lost more than 2.5 hours every month, which is why they generally encourage you to have replica sets. This is why you don't just run one RDS node production. And there are various SLAs available out there. Then also you have to think about multiple availability zones. And most of the focus is obviously RDS because RDS is so far ahead compared to the competition. And with RDS, you can have enhanced durability. You also have definitely got increased availability, but I'm sure you realize that automatic failover tends to be slow. It can take up to 10 minutes. And even creating a new instance, even with a 5 GB database, can take 5-10 minutes easily. The GUI is by far the best, but the replica sets in RDS don't give you a usable read replica. That's why the cost is only about 50% of what another machine would cost. So that's why I say it's probably DRBD underneath. With regards to external replication, with MySQL 5.6 only, you can do actually replication from RDS to say your own private host in the data center. This didn't work before with MySQL 5.5. If you ever think of wanting to replicate into RDS, another use of function replicator right there. So with regards to HA, always remember that node provisioning can be slow. Always have multiple backups. Sometimes you have bad nodes, so you just kill the node and start another one. One thing to note about automatic upgrades, the cloud is fun, but with automatic upgrades also comes occasionally automatic pain, because MySQL, even in point releases, can cause regressions. You can test these regressions when you are running it yourself, but if it's automatically upgraded for you, you may get suddenly realize the query cache stopped working when you had partition tables in RDS. You may not be so happy. Sharding is the idea that not all data lives in one place. Sometimes you can partition the data alphabetically, sometimes you organize it by postal code, sometimes you just organize it by plain users. So in the old days, Flickr would say one shard would have 400 users on it, and then you would rebalance the shard that user takes up more storage space and so forth. Anybody know what fruit that is? It's a durian, the king of fruits. So how do you shard? Typically, many people write this in the application, because writing sharding into your app shouldn't take you maybe even more than 20 lines of code sometimes. Or you can use many tools like Spider, Function Replicator, or Tumblr's Jetpans that I recommend. Spider is a storage engine that basically allows you to automatically partition your data across multiple InnoDB backends. So your application looks at it as one big database server, but Spider actually manages the InnoDB backends for you. So it actually does automatic partitioning. This is kind of handy. Spider's been around now since 2008. The only reason you probably not heard of it is because MySQL never shipped it. But it comes with MariaDB 10 as a default. So now we expect more people to start using and playing with it. Tungsten, in the open source version itself, allows you to do automatic sharding controlled by JMX bean. The primary use for this is obviously geographic replication. But it does require application to have changes, which is why it's not so popular for you people to just roll out. Then there's Tumblr's Jetpans. By far the best written in Ruby is a library. Allows you to clone replicas, rebound shards, etc. And you can use any version of MySQL for Corona Server for all your nodes. But as an aggregator node, because the only one that supports multi-source replication today is MariaDB 10, you have to actually have a MariaDB 10 node there as well. And that's generally what Tumblr's architecture is today. Then there's another very promising one called Vitesse from Google, or should I say the YouTube team at Google. Because Google is largely rolling out MariaDB throughout the infrastructure, it has also got MariaDB support. But it's fully written in Python. This actually serves all your YouTube videos today. The disadvantage of this is that if you go to GitHub and look at it, you go, how do I install it? Then you go check out the README file. There are like 2 paragraphs that tell you how to install it because the README file is incomplete. So unless you know Go, unless you know what you're doing, setting this up is actually really hard. So I would not recommend the solution overall.
Yes.
Yeah. Overall, Michael Stonebreaker 2 years ago said that for Facebook, using MySQL is a fate worse than death. So this T-shirt was printed by a bunch of the Facebook DBAs, where they're actually running a lot of MySQL, naturally speaking. And I'd say mastering the ecosystem takes time. Today, I've just given you an overview of HA solutions. We haven't even gone into the overview of storage engines, etc. So, with nearly 20 years of baggage, there are lots of solutions, lots of half-baked solutions, lots of solutions that have been improved over time, etc. So you need to generally check out the entire ecosystem before realizing that, MySQL is not the right solution for you. That's why a lot of the NoSQL solutions popped up, and MySQL is catching up with all these things, including like JSON, document data types, and so forth. Two very useful books: High Performance MySQL and MySQL High Availability. I'm sure you can get copies of this anywhere, really. And with that, I finished in 49 minutes and 20 seconds, so we have time for some Q&A. Or you can also email me if you have any questions, naturally. But yeah, any questions now where I can extend? Okay.
Yeah, I definitely want to.
The slides, they will be at SlideShare, obviously, and at the SeaGL website where they upload it, I guess. Any other questions? Slides. Well, if you have no other questions, please come to my MariaDB talk later if you have the time. If you're interested to know about MariaDB, which is inside pretty much all your Linux distributions now, as a default, pretending to be MySQL. Well, thank you for listening then.